Okay, I'm back. Got my colored pencils. Okay, so I'm drawing my base function there. All right, boop, 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 boop. There's y is equal to 2 to the x. That's this one. And then when I draw y is equal to 2 to the x plus 1, I'm going to do mapping. So I'm just going to draw this. So at negative 1, it should be 1.5. So at negative 1, it's 1.5, which is about here. And at 0, it's going to be up at 2. And 1, it's going to be up at 3. And it does bring up an interesting idea. And what you'll see is, first of all, don't forget that there's an asymptote. It makes those sound effects too. At y is equal to 0. My final asymptote is going to be for my transform function, is going to be right here. So this is the value that it's going to approach and never quite get there, because it never quite gets to 0, and then I'm always going to add 1 afterwards. So if it almost gets to 0 and add 1, then it's almost going to get to 1. And so that helps you, just like any reciprocal function, it helps you set up the sketch to your function. And what you're going to see, of course, this moves up 1, this moves up 1, this moves up 1. So y is equal to 2 to the x plus 1. Okay? And the asymptote is going to help you draw that value that it approaches, okay, as well. So this would be a vertical shift. Up 1 unit. Nothing crazy. Now this one is 2 to the x minus 1. Okay? So now I have to look carefully at it, and I have to say to myself, okay, my base is 2, so I'm going to have the same table of values. So I'm going to go ahead and sketch it now. 0, 1, 1, 2. I'm getting good at this. And a half. There's my sketched function, right? And I got my asymptote there. Almost sounds like you're about to swear like shiitake mushrooms, but you say asymptote, so you can get away with it with your parents or something. Don't tell them I said that. Okay? So this is y is equal to 2 to the x. And then if y is equal to 2 to the x minus 1. Now what does that look like? Well, notice that it's up in the exponent. So that's actually a d value of plus 1. So that means I take my normal table of values, negative 1, 0, 1, 0.5, 1, 2, okay? And I'm going to transform my x values now by adding in my d value. My d value is a positive 1. There's no k value to factor out because there's nothing beside the x. So what do? Well, for my new table of values, okay, it's going to be, the y values aren't going to change, so I go 0.5, 1, and 2. And then my x value is going to be negative 1. That's going to turn into negative 1 plus 1, so that's 0. And that's going to be 0 plus 1, so that's going to be 1. And that's 1 plus 1, so that's going to be 2. Remember that d affects x values by adding or subtracting to them. In this case, it's a plus 1 because the d is positive. Okay? And then when we draw that function, what does it look like? Well, again, I've got 0.5, that's right here. I've got 1, 1, which is right here. And I've got 2, 2. Now what I also do is I transform the vertex. But the vertex, because it's entirely based on a y component, it's not the vertex, the asymptote is already y is equal to 0. But it does help me as far as what it approaches. It still approaches the same value. And it may not look like I've shifted it to the right, but there's such a very small change that I've actually have shifted it to the right. So think about it for a long period of time and you're fine. Okay? And so this is going to be, again, a horizontal shift to the left, oops, right, my other left, this way, okay, 1 unit. And you can say shift or you can say translation if you want to. Either is fine, although translation of the language is a little bit better. Now we got a little bit more going on here. Now we've got an a value and we've got a k value. Sorry, a c value. Okay? No k value, no d value because there's nothing else up in the exponent. Okay? So now I'm going to modify this one. Again, same table of values because my base is 2. I know there's a lot of numbers, so it's starting to hide now. So my negative 1, 0, 1, my base is, 0.5, 1, and then 2. Okay? So that's my base, but I have an A value of 1 and my C value is 1. Now, for those of us who are starting to get the hang of it, what we are going to do is we're going to say, okay, we've got our basic function, which is here, and here, and here, with my asymptote, and I guess I'll color those in a little bit better so we can see them. Okay, with my asymptote, I've got this. Now I'm going to do my step-by-step transformations. So the first thing I'm going to do is 3, the A value of 3. I'll go ahead and I'll do a mapping over here too, and hopefully, well, it should sort of corroborate. But either way, we've got a Y value of 1, and remember, A multiplies Y value. So the Y value is 1, so I triple that, so that becomes that. Okay, this Y value here is 2, so I triple that and it becomes 6. And this Y value is 0.5, and I triple that and it becomes 1.5. Now, this is step by step. Okay? The asymptote is still multiplied by A. But my asymptote, remember, is that Y is equal to 0. So my asymptote, kind of trying to draw it in there, is also at Y is equal to 0, because 0 times 3 is still 0. Okay? So that's going to be Y is equal to 3 times 2 to the X. And that, of course, is Y is equal to 2 to the X. And I guess I'll do blue. It's the most different one. So then what do? I shift everybody up 1. So I take my red function, I shift it up 1. Red function, shift it up 1. Red function, shift it up 1. And, excuse me, my asymptote, I shift up 1 as well. Everybody gets shifted up 1, so Y is equal to 1. Remember, my asymptote's always Y is equal to C. And my C value is 1. So then I go like that, and I approach that value, and then I take off. Okay? So it's a little bit stretched vertically, as you can see, but it approaches, and it's also been shifted up 1. So, X, Y. If I was to do the mapping, what would I do? Well, remember, I would take my Y values, and I would multiply them by 3, so that's 1.5. 3 times 0.5 is 1.5, and then add 1. 1.5 plus 1 is 2.5. My X values stay the same, because there's nothing to modify the X values there. For this one, okay, I would multiply this Y value by 3 and get 3, and then add 1 and get 4. And for this one, for 1, I would take my 2 for my Y value. 3 times 2 is 6, plus 1 is 7. And then we just have to see it. Negative 1, 7, do we see a point? Or sorry, 1, 7. 1, 2, 3, 4, 5, 6. Oh, there it is, 7. 0, 4, there it is there. And negative 1, 2.5. That's 1, 2.5. There we go. Okay? So that's a couple of things. That's going to be a vertical stretch. Okay? By a factor of 3. And then it's also going to be a vertical shift. Vert, shift, up 1 unit. Okay? Now, in this one, the only thing that we don't have is a K value. Sorry, we don't. Oh, maybe I should have put a K value or something in there. Silly rat. Well, I do another one where we do everything a little bit later on. Okay? So here we have a D value. It's negative 3. And we have a C value of 1. Okay, we've got the same table of values. Negative 1, 0, 1. You're probably getting the hang of it. It's a base 2. We do tend to use not too many crazy bases when we're sketching things, just to make life a little bit easier on you guys. But you do have to understand what these transformations are going to do, no matter what the base is. Even if it was like 0.85 or 0.73 or, I don't know, pi or something like that. Okay, we do have to understand that idea. So my base function is here and here and a half. And there it is. And then we've got an asymptote. And then what we have is Y is equal to 0. Okay, so that is what it is. Now what I'm going to do, okay, is I'm going to take my X values, and I'm going to take my Y values, and I'm going to shift them. And I'm going to shift them all at once. So maybe I'll use my red here. Okay, I'm going to take it, and I'm going to shift my points to the left 3 and then up 1. That's not a minus 1, that's a positive 1. Okay, so I'm going to go to the left 3, 1, 2, 3, and up 1. I'm going to go to the left 3, 1, 2, 3, and up 1. And I'm going to go to the left 3, 1, 2, 3, and up 1. And don't forget, you're going to have to move your asymptote. I guess you could move it to the left 3 if you wanted to, but it's an infinite length. But it's got to go up 1, okay? And so the function's going to look like this. Okay, and these are the 3 key points that help us map it out. We don't have to do any other points necessarily, but if you want to be more accurate, you can go ahead and plot, a 2 all the way up at 4, and 3 all the way up at 8, and so on. And then that way you could see a little bit more about where the proper trajectory for that function is. But that's what that function looks like. And again, if we did our table of values for using our mapping rule, remember we have something that modifies x and something that modifies y. So first I'll go that d is equal to -3. -1 minus 3 is -4. 0 minus 3 is -3. 1 minus 3 is going to be -2. This is going to be, I add the 1. Remember my c value is 1, so that's going to be 1.5. 1 plus 1 is going to be 2, and 2 plus 1 is going to be 3. Okay? And so now to check those right, -2, that's up at 3, good. -3, boop, is up at 2, and then -4, boop, is up at 1.5. So I know that I did that right. Okay, so that's going to be a vertical shift up 1 unit, and that's going to be a horizontal shift to the left 3 units. Okay, so that's that. Let's do some crazier ones. Oh, I got to put that away. That's a different video. Let's do some crazier ones. Okay, let's start doing some reflections, and then we'll start putting everybody together. Again, now this is my base function is a 3. Okay, so my x and my y still -1, 0, 1, but instead it's going to be 3, it's going to be 1, and it's going to be 1/3, or 0.33. Okay? All right, now in this case, we've got an a value that is -1. That's the only transformation value, a, k, d, and c, transformation factor, if you will, that's in there. Okay, so we have to think about what that's going to do. It's going to take all my y values and multiply them by -1. So here's my basic parabola, my basic exponential function. It's 1 and 3. It's a little different this time. And that's a 1/3. Obviously, the 1/3 and the 1/2 pretty much look the same. And it's got the same asymptote at y is equal to 0. Now what happens? Well, I stretch things, I reflect these things in the x-axis. It's a vertical reflection. So what I do is I take my y values, which is 1, and I multiply them by -1. So 1 becomes -1. 3 becomes -3. 1/3 becomes -1/3. And my asymptote, 0 times -1, is still 0, although I'm doing my best. Y is equal to 0 there, right on top of it. Okay, and so you draw your function. Again, I'm drawing it from right to left just because it's easier, but from left to right as you go approaching that value. Okay, if I want to do my mapping, my x values are unaffected, so -1, 0, 1, because that's just an a value. And I take my a value and I get -0.33, and the 1 is -1, and the 3 times -1 is -3. Nothing too crazy. So it's going to be, a reflection in the x-axis, or if you prefer, a vertical reflection. Okay? Not too crazy. Now we have an a value that's 0.5. Not much different. And I think I'm going to use a mapping only for this one. I'm not even going to sketch my base function. Okay? I'm going to gain some confidence with the mapping. So it's going to be 0.33 repeating. And it's going to be 1, and it's going to be 3. Okay? And then I'm going to do my mapping. So for my x and my y, my x values don't change because I have an a value that only affects y values. So -1, 0, 1. I'm going to take 0.5 and multiply it by 0.33. Okay? And 0.5 times 0.33 is going to, I can't use my phone. 0.15 plus 0.15 is 0.16. So it'll be about 0.165, 165, give or take, okay, ish. Okay, the 1 times 0.5 is easy, that's just 0.5. And the 3 times 0.5 is 1.5. Okay, my asymptote is going to be multiplied by 0. Sorry, my asymptote is y is equal to 0. It's going to be multiplied by 0.5, which still leaves it at y is equal to 0. Okay, and then the final function that I'm going to draw, okay, maybe I shouldn't do it in pencil. Maybe I should just do it in, let's use blue. Okay, we'll go y is equal to 0. There's my asymptote. And some people like to draw their asymptotes first. I think it's a very good idea to do that. Okay, so it's going to be 0, 0.5, which is going to make it really close there. It's going to be 1, 1.5, which is going to be right about there. And it's going to be a negative 1, really small, 0.165. It's very difficult to see the transformation unless you have it side by side with the actual graph, but it really has made it a lot shallower, if you will. If you want to look at the actual function, the parent function, it's going to look like that. That's going to be up at 3. That's going to be down at 1/3. And so that's going to look a lot steeper. Okay, that's y is equal to 3 to the x. And that's y is equal to 0.5 times 3 to the x. Okay? And remember, even if I don't put a bracket there, it only affects what it's immediately beside. Okay, and the x is right beside the 3. Okay? 3 to the negative x. I like this one for a couple of reasons. Okay? I want to use the mapping technique here because it specifically shows me something cool. First of all, this is a k value of negative 1. That k value of negative 1 means that it's going to be a reflection, but it's not going to be vertical, it's going to be horizontal. So I'm going to go negative 1, 0, 1. And then I'm going to go, it's a 3, so it's going to be 1, 3, and that's going to be 0.33. Now, because it's a k value, my y values are going to be unaffected. Now I'm going to show you this because it's actually pretty cool. Okay? Now, what does it do? It takes my x values and it divides them by negative 1. Negative 1 divided by negative 1 is 1. 0 divided by negative 1 is 0. 1 divided by negative 1 is negative 1. Now, if you look at this table of values quickly and carefully, what you're going to see is something quite interesting. So first of all, the base function, the parent function is 0, 1, 1, 3, and negative 1.33. And that's y is equal to 3 to the x with the asymptote. Now we know the asymptote for this new function is not going to get modified. It's never modified by anything other than a c value, to be honest. Okay? And in this case, we don't have a c value out here. All right? But what's really cool is this. Negative 1 is actually up here at 3. 0 is at 1. And 1 is at 0.33. Well, even if I did this step by step, this is not mind-blowing because it's going to be the same distance on the other side of the mirror. The mirror is the y-axis. It's a horizontal reflection. This is on the mirror, so it's going to be the same distance, which is 0. And this is 1 away, and this is 1 away, so that's going to go 1 away. So it's not crazy, but what's important is, what does it turn into? What it turns into, this is y is equal to 3 to the negative x. But what it also turns into is, this is the same table of values as y is equal to 1/3 to the x. Okay, 0, 1, that's for sure. The 1 value is 1/3, 0.333. And then the negative 1, which is usually all the way up top here, is going to be the flip of 1/3. What's the flip of 1/3? It's 3. So you go from an increasing function to a decreasing function. An increasing function when this is 3, a decreasing function when this is y is equal to 1/3 to the positive x. Remember, we flipped the base, and it becomes a positive exponent. And so that's y is equal to 1/3 to the x as well. So this is going to be a horizontal reflection. And I'll do some nicer notes using my class notes when we do these. A horizontal reflection in the y-axis. And that's it. This one was a vertical compression. by a factor of 0.5. Okay? Now, whether you notice it or whether you don't notice it, that is a property of exponential functions that we would like you to understand and understand really well. Okay? Now, this one's got a lot going on with it. Okay? One thing that it has going on with it is an a value of -2. It's also got a k value of 0.5. Now remember, we multiply by the a value, the y values by the a value, and we multiply the x values by 1 over k, or we divide by k. So multiply outside like it looks. K looks like it multiplies, but you do the opposite inside, which is divide. And when you divide by 0.5, you're actually doubling. So a small k value, if you remember, is going to be a horizontal stretch. Okay? Now we're going to do a table of values, but we're also going to do a step-by-step. So what we're going to do is we're going to do our basic function, which is 3. So x, y, -1, 0, 1. That's going to be 0.33. That's going to be 1, and then that's going to be 3. Excuse me, I'm going to erase that. 0.33, etc. Okay? All right, so we sketch that function. We go 0, 1, all the way up to 3. Down here at 1/3, we got our asymptote at y is equal to 0. So there's our function. There she goes. Okay, now what are we going to do? Well, this is going to make it a vertical reflection and a vertical stretch. Okay, now I'm going to do them both at the same time. I'm going to take my y values and I'm going to multiply them by -2. My y value is 1, multiplied by -2 is, it's 1 space. It's going to be 2 spaces, twice as many spaces on the other side of the mirror. This is going to be 3 spaces. It's going to be twice as many spaces, so 3 is 6 spaces on the other side. See, 3 turns into 1, 2, 3, and then 1, 2, 3, 6. Okay, this 0.333 is going to be double that, but it's not even going to be up to 1 because double 0.3333 is 0.66. Okay, and then we do that, connect the dots. And what does it approach? Well, remember, the asymptote doesn't change unless I change the c value. So it's still y is equal to 0. And this is y is equal to -2, 3 to the x. Now I'm going to do the 0.5 deal. Okay? Remember, when I divide by 0.5 the x values, what I basically do is I double them. Okay? So this distance is 1. I'm going to double that distance. Maybe I should do that in blue. I'm going to double that distance. Okay? This distance is 0. I'm going to double that distance, which of course doesn't make it go anywhere because 2 times 0 is 0 for the x value. And this x value is -1. I'm going to double that distance all the way over to there. My asymptote stays where it is at y is equal to 0. Pretty ugly looking, really, the asymptote, but at least you get an idea that the asymptote hasn't moved. And what you're going to get is the function stretching out that way and stretching out this way. So it's going to be a horizontal stretch. Okay? So we get a vertical stretch by a factor of 2. We get a horizontal stretch by a factor of 2. And then we get a vertical reflection in the x-axis. Okay? Now, table of values, when I do those table of values, what I'm going to want to do is modify my x's and modify my y's. So I've got my basic one. I'm going to take my -2 and multiply it by 0.33, and I get -0.66. I'm going to take my 1 and multiply it by -2, and I'm going to get a -2. And I'm going to get this, and I multiply it by a -2. 3 times -2, and I'm going to get a -6. Here, I take my k values, and I divide by my k values. So -1 divided by 0.5 becomes -2. 0 divided by 0.5 is going to be 0. And 1 divided by 0.5 is going to turn into 2. And as you see, 2, -6, 2, -6, there we go. 0, 2, 0, -2, there it is. And -2, and then 0.6. Well, we can guess that's about correct when we do that. Now, this one is crazy. It's got everybody in there. Okay? I don't know if I'm going to do the mapping in my head necessarily. I may make some boo-boos, and I don't have a lot of room to work here, so I'm going to do step by step. Okay, but I am going to do the D and the C value all at once. Okay? First things first, my A value, I'm going to put it over here, is going to be 2. Okay? My K value is going to be 4. But remember, you have to factor out the K value. So that's going to become x minus 0.5. And then plus 1. Okay, you've got to factor that so you can see what your D value is. And that's going to be a positive 0.5. So it's only going to be a shift of 0.5. Maybe I should have made that a 4 or an 8 or something. But it is what it is. And then for my C value, it's going to be 1. Now, because of all these changes, I've got my basic parabola here. Sorry, my basic exponential here. Y is equal to 3 to the x, negative 1, 0, 1, 0.33, 1, and then that's going to be 3. Okay, I'm not going to do mapping unless I try it in my head. And even then, I'm going to need to think about it. Okay, now we may get some points that are really scrunched, but bear with me. Okay, the final asymptote I know is going to be at y is equal to 1. Okay, every other asymptote before I do my C value is going to sit right here. So I'm only going to draw one asymptote so it doesn't get too crowded. Okay, and y is equal to 0. Okay, so we're going to assume that asymptote's the same for all of them. I want to draw with 15 different colors. First, I'm going to go I'm going to draw my base parent function, which is this and this and this. And then I'm going to do my K value, which is 2. That's going to double my Y value, so it's going to make that go up to, instead of 3, it's going to go up to 6. Instead of 1, it's going to go up to 2. Instead of a half, it's going to go up to 1. I'm just going to color these points a little bit better so we can see them, because remember, we have to branch from one to the next to the next. And the asymptote is going to stay at y is equal to 0. Okay? Then I'm going to do my K value, and this one's going to be a tough one. Okay? I have to divide all my x values by 4. Okay? So this x value of 1 becomes 1/4. This x value of 0 stays right here. This x value here becomes 1/4. So it's going to turn into this really, really super de-duper. And it is a compression, because I'm dividing by 4, right? It is a compression. I'm still going to have an asymptote at y is equal to 0. Then what I'm going to do, finally, I'm going to do this in pink, is I'm going to, so that's, red is going to be y is equal to 2 times 3 to the x. Blue is going to be y is equal to 2 times 3 to the 4x. And then pink is going to be the final. Okay? That's going to shift to the right 0.5, and in this case, it's going to go up 1. So I'm going to go to the right 0.5, which is going to bring it over to here, and then go up 1. And it's going to bring it to there. That's going to take this point to the right 0.5 and go up 1. And this one's going to go the right 0.5 and up 1. And so my final function is going to sort of look like this. And the asymptote is going to be here at 1. Y is equal to 1. Now, it's pretty ugly, which means maybe we're going to want to do our mapping. Or maybe we're going to hope that our mapping rule graphs this y is equal to 2, 3, 4, x minus 0.5 plus 1. It's going to do that one accurately. Okay? So what am I going to do? Okay, I got lots going on here. So first of all, I'm going to take my x values, and I'm going to divide them by 4. So that's going to be negative 0.25. And then I'm going to add 0.5. So negative 0.25, add that value, it becomes positive 0.25. Okay? My 0, that's not going to be too bad, because when I divide it by 4, it's still going to be 0. So that's going to become a positive 0.5. Remember, I'm going to add my 0.5 to it. So 0 plus 0.5 is 0.5. That's a positive as well. And then my 1, I'm going to divide it by 4, so that becomes 0.25. And then I'm going to add 0.5, so that becomes 0.75. Okay? For my y values, it's not going to be as bad. I'm going to take my y values and double them, so that's going to be 0.66, and then I'm going to add 1, so that's going to be 1.66. I'm going to take my y values and double them, 2, and then add 1, 3. I'm going to take my y values and double them, 6, and then add 1, 7. Now, 0.75 is like right here, all the way up at 7. Oh, there it is right there. 0.5 is right about here. It's really scrunched in there. All the way up at 3. Hey, there it is right there. And then 0.25 is really close to the y-axis. And then 1.66 is like 1 2/3, which is about here. And so there you go. And there is your exponential function. Kind of ugly. It would have been nice if I had a bigger scale. Okay, if you were to zoom this in, you're going to like say to yourself, that's a mess. Have a look. Hopefully I'll be able to do it a little bit more accurately on the smartboard. But you'll get around to playing with those. Get yourself some grid paper to do this. And finally, we describe, okay, we've got a vertical stretch by a factor of 2. We get a horizontal compression by a factor of 4. We've got a horizontal shift to the right, 0.5 units. And then we have a vertical shift up 1 unit. Okay? And that's our transformations, and that's our homework, and I want you to try some of these guys out. Have fun with that.